Hello, ladies, gents, and everyones. I missed you. It is Thursday, August 26th, and we're here to talk about this week's space and astronomy news. So it turns out we're not done with the Lunar Human Landing System drama yet. So to catch you up, back in April, NASA awarded about a $2.9 billion contract to SpaceX for the human landing system that will take astronauts from the spacecraft to the surface of the moon for the upcoming Artemis missions. The losing bidders, Blue Origin and Dynetics, protested this contract award, which halted all work on it while the US Government Accountability Office investigated. Now, the GAO released their report at the end of July and said basically that NASA had awarded the contract appropriately and that it was free to go ahead with the SpaceX award. So they immediately got to work and sent a $300 million payment to SpaceX right away. However, that didn't last long because Blue Origin was not satisfied with this decision and they decided to sue NASA in federal claims court. While this lawsuit is ongoing, NASA has voluntarily agreed to a temporary work stoppage on the SpaceX contract, lasting until November 1st, under the agreement that this will be an expedited litigation schedule, so that it will be resolved by November 1st. This work stoppage means that NASA can no longer pay SpaceX and that NASA can't work with SpaceX. However, it can't control what SpaceX does internally. However, any work that SpaceX does towards this contract, they run the risk of not getting paid for it if it doesn't end up going through. However, because the development of the HLS Starship is in line with other SpaceX objectives, it seems quite likely that they're just going to go ahead and continue working on this internally, although I have not seen any statement that they released specific to this matter. The first hearing for this case is scheduled for October 14th. In slightly better news for NASA, the James Webb Space Telescope completed all of its final testing this week. Now, this might sound familiar because I've been talking about this for all of the major milestones along the way, but now really everything, literally everything in the testing site has been done, and now the telescope is being prepared to be shipped to the launch site in French Guiana in South America. The launch date is not currently set. While the telescope itself is on track for that October 31st launch that we were all hoping for, the launch vehicle, the Ariane 5, had delays due to some vibration issues, and that's caused their launch schedule to slip. So we don't have an official date yet, but we're expecting it to be probably sometime in November. Once it launches, it will take a month for the telescope to reach its orbital location, and then once there, it will have to unfold its sunshield in what will be one of the most stressful processes of all time, I imagine. And then it will take months for the telescope to kind of prepare itself for observations. There has been so much money, time, and talent, just an effort that has gone into this telescope. It is going to be hugely important for a wide range of astronomical research areas. So, I'm just going to be watching every single move of this with bated breath, as I'm sure most of you will as well. OFT-2, Boeing's planned test mission to the International Space Station, has been indefinitely postponed after some incorrect valve position indications in the lead up to the planned launch on August 3rd. The rocket was rolled back from the launch pad for further investigation, and it was discovered that several of the valves in the Starliner propulsion system did not open as designed. Now, these valves control things like the ability to abort and do in-orbit maneuvering, so they're pretty important. So now the Starliner spacecraft has actually been removed from the rocket and sent back to the factory for further investigation until they can get this issue resolved. It's unclear how long this is going to take, but this is a huge issue, so it definitely needs to be 100% resolved before they can even think about planning a new launch date. The NASA mission OSIRIS-REx spent years at the asteroid Bennu, culminating in the successful sample collection last October. The mission has since left the asteroid May of this year and is on its way to take that sample back home. But one of the things that the mission did was enable really detailed measurements of the asteroid, which allowed astronomers to really precisely pinpoint its future orbit. This is very important because Bennu is one of the two asteroids that are most likely to impact the Earth in coming centuries. Now, most likely does not mean that it's likely. In fact, this new study found only a 1 in 1,750 chance that Bennu will impact the Earth in the next 300 years or so. Still, given the possible outcome of such an impact, even with these very small probabilities, we definitely want to be keeping an eye on this and doing our best to predict the future trajectory of this asteroid. Now, it might sound like a pretty simple thing to just calculate an orbit, but there's actually a lot of really small effects that are important for small bodies like Bennu, like the Yarkovsky effect, Poynting-Robertson drag, the gravitational pushes from the other planets, and even other asteroids. And in fact, they even investigated whether the sample collection event itself altered the trajectory of the asteroid, although they found that it was actually negligible. But this is the sort of thing that has to be considered, and so it's really difficult to really precisely pinpoint exactly what's going to happen. This new analysis predicts September 24th, 2182 as the most probable date of impact, so mark your calendars. Speaking of orbits, astronomers have determined a new possible set of orbital parameters for a hypothetical ninth planet in the solar system, very creatively nicknamed Planet 9. Now, the evidence for the existence of Planet 9 lies primarily in the orbits of a few small bodies orbiting out beyond Neptune. These bodies are on eccentric orbits, that is, non-circular, and they're aligned in their non-circularity in a way that seems unlikely to have happened by chance, suggesting some possible external force that would align them this way, such as an exterior planet. Now, there is some disagreement between astronomers about whether or not this clustering is in fact statistically significant, partly due to the very small number of bodies. In this most recent study, they examined 11 trans-Neptunian objects, as well as some uncertainty about the statistical biases in the surveys that have detected these objects. So this new study asserts that indeed the clustering is statistically significant, and they use statistical techniques to provide possible orbital parameters for the planet, which they find to be about 6 times the mass of Earth and located anywhere from 300 to 500 times as far from the Sun as Earth is. The new analysis also provides guidance about where on the sky Planet 9 might be located and how bright it might be, and this is very important information for astronomers to be able to potentially detect this planet and confirm its existence. So this is a very cool new study. And just like we're always learning new things about our own solar system, we're still learning about our own galaxy as well. So when you see pictures like this artist's concept of the Milky Way, you might think, hey, we have a really good idea of what the Milky Way galaxy looks like. And I mean, we do have a pretty good idea, especially considering just how difficult it is. Imagine just sitting on your couch and trying to draw a very detailed map of your entire home that you'd never have seen before. It's very hard to do. But astronomers do know that the Milky Way galaxy is a spiral galaxy with several spiral arms, including one called the Sagittarius arm. And astronomers recently discovered a very interesting new feature in this arm of the galaxy. They were able to combine data from NASA's recently retired Spitzer Space Telescope, which can actually peer through dust clouds to observe newborn stars, with ESA's Gaia mission, which takes very detailed distance measurements to stars, to actually construct kind of a 3D image of this section of the Sagittarius arm. And what they found is that there's a feature that kind of sticks out from the arm. It's about 45 degrees different in orientation than the rest of the arm. So it's like a little splinter or spur off the arm. Now, astronomers have seen this kind of feature in other spiral galaxies, but this is the first time it's been detected in the Milky Way. It's really exciting to add to the picture of our own home galaxy, and of course there's so much more to learn about galaxies in general, and this is a really important piece of information to help us with that. So very cool. Well, that's all I have for you this week. Thank you so much for watching. I will see you again next week. Have a good one. Bye.